Hello, am I audible?
Yeah.
Yeah.
Okay, I'm sharing the screen. Visible?
Yep.
Yep.
Okay. So, starting with today, we will be covering what is a battery, what is the battery management system, and some safety rules regarding it. So, let's begin. What is a battery? Just simple answer.
Something that stores electrical energy
Yes.
in the form of chemical energy usually.
Okay. So, yeah. So we will be covering how a lithium-ion battery works, difference between lithium-ion and lithium polymer. What is the battery management system BMS? What are charging methods and about heating and safety. Just give me a minute. Yeah. Beginning with it. How many of you guys have heard about lithium-ion battery earlier? Okay. Just tell me a few of its use cases.
In mobile phone, laptops, and even in electrical car, and even in that cell that we use, many of that rechargeable cell are made up of lithium ion.
Yes. So, how many of you guys know how does it work internally? What is the chemical composition of it? Pratik, is it from before or do you know already?
It's from before.
Okay,
And
okay, okay. So we'll try to cover that. Before coming to that, a very basic question: what is the difference between a practical power source and a ideal power source?
I mean, in practical, in ideal, you have like zero internal resistance and you don't have any losses while charging and discharging. It will always get charged up to 100% and discharged with 100% without any loss. In ideal, you have you do have some internal resistance, you have power losses, and the discharge and charge is not uniform as well.
Yeah, mostly correct. The thing is, in an ideal source, there is no discharging at all since there is no internal resistance. It will give same charge again. Uh, no. What I meant is there will be no voltage drop due to discharging in a ideal power source. Like uh, like there's a 7.4 volt battery. It's supposed to store about 5000 mAh of mm, uh, its capacity. So it will supply uh, 7.4 volt for a stipulated time, giving some amount of current. And after supplying whatever amount of current it had, it will just switch off. In the practical source, it doesn't work that way. The 7.4 will dip to until 7 at a very good battery source. It can dip to until 5.5 to 6 in a moderate type of a battery.
Has any one of you heard about standard battery?
Which battery? Could you repeat once more?
Standard battery. Standard battery.
Standard, STANDRD.
Yes. Standard cell या फिर standard battery.
No, actually.
So yeah, basically what a standard battery is. Uh, it is used to uh, like compare the voltage between battery and ideal voltage. So what it means, like if you are uh, like measuring 7 volts, then it will be giving you a ideal 7-volt source, but it can't provide you certain current. Understood? So basically, you are going to use a standard battery or standard cell to compare the voltages, but you can't use it to drain your current. So what standard battery does is just a comparison. Normal batteries gets clipped when current is wrong. Yeah. So
Acha, but we can use multimeter to do that, na? So why do we need a standard battery?
Uh, how does a multimeter work?
I don't have any idea about it.
Okay, so in a multimeter, it has a series of resistances and uh, in parallel or series based on whatever measurement you are doing. So when you are doing a measurement on uh, a multimeter, there is some amount of tolerance error which comes due to internal resistance of its own multimeter. So the thing is, if you are measuring voltage across you are measuring resistance of a resistor. So when you go to resistance mode, the probes will apply a voltage, some standard voltage across the resistor. They will measure the current flowing through the resistor. But the problem is the same two probes are used for giving power source and also measuring current. So which is why multimeters have some tendency of errors, which is why in advanced studies you will learn there are two mechanisms of multi measurements. One is two probe method, another one is four probe method. Four probe method is always better since two probes are used to supply the standard voltage and two probes are used to measure the current. So in a battery, a multimeter will always give faulty readings comparatively. Understood?
Yeah.
Okay. So moving on, I'll just show there's a video based on how lithium ion battery works. Then we'll come to this. I guess, yeah. Just a minute. By the way, is the video audible now?
No.
No.
no, it
Okay,
is.
give me a minute.
Electric vehicle battery. The most popular is lithium ion battery. In today's video, let us understand how lithium ion battery works. Consider a simplified lithium ion battery cell. The anode is made up of graphite. The cathode is made up of lithium metal oxide. The electrolyte is made up of lithium salt. The separator is made up of polyethylene polypropylene. Let us understand the working. During charging of the cell, as you can see, a charger is connected in between the electrodes. The lithium is present in form of lithium metal oxide at cathode. When current I flows from charger through the cathode, the lithium itself is released as positive ion from lithium metal oxide and it travels through electrolyte to anode. At anode, it combines with carbon electrode to form lithiated carbon. The electrons flow in opposite direction. At cathode, the lithium metal oxide produces lithium ion along with metal oxide and electrons. At anode, carbon combines with lithium ion to form lithiated carbon. This is a total cell reaction as you can see. During discharging of the cell, as you can see, a load is connected in between the electrodes. The lithium ions are present at anode in the form of lithiated carbon. The current I flows through load from the cathode and electrons flow in opposite direction. The lithium ions get released from the anode and travel through the electrolyte towards the cathode. At cathode, they again combine to form lithium metal oxide. At cathode, oxide combines with lithium ion to form lithium metal oxide. At anode, the lithium ion is released from lithiated carbon. This is the total cell reaction as you can see. Thank you for watching. If you like the video, do like, share and subscribe to always. Also
Hello. Yeah, so it gave a pretty much concise idea of how a ion battery works. Still, I will just explain once again. Let me just stop sharing from here. Okay, so the basic components are there's an anode and cathode. There's a separator. Okay, is it correctly visible?
No, it's actually in the
So
corner.
Uh,
नहीं नहीं social just drag it.
you can drag on
It's
your
actually,
screen
yeah,
itself actually. You can
yep, it's
drag
visible.
across the whiteboard yourself.
Yeah,
Okay,
yeah.
yeah. So and depending on charging or discharging, there is either a power source on the opposite side or there's a load. So we'll come to that. There's electrolyte throughout. Okay, so this one. for some reason dragging. Just a minute. So this is your cathode with lithium cobalt oxide, and this is your graphite. Uh, does anybody remember how graphite works? Like, what's there in graphite?
Yeah,
Like
are
it's
you
a two
talking about
dimensional
its a
compass.
structure? Acha, Pratik.
Yeah,
Continue, Such.
Well, like,
yeah. Please go ahead, share.
So it's like a 2D carbon lattice. And between layers, it has van der Waals forces of attraction that keep it packed
Yeah,
together.
yeah, exactly. So just a fun question. Does anybody know if you isolate a single layer from graphite, what will be it called? I actually gave the answer. It's graphene. So these van der Waals forces between the graphite is weak. So what you can do is uh, you can exfoliate a single layer and it gives you graphene. Just a fun fact. So coming to the battery, what happens is here lithium cobalt oxide is present. So just a minute. Yeah, okay. So these lithium ions dissociate from cathode, making LiX CO. No, this one. Sorry, XCO oxide, and this means there are X lithium ions here. So since there's a battery attached here, power source, uh, the electrons dissociating from this cathode go towards the battery, and electrons are supplied from here to here. So these lithium ions flow from the electrolyte and intercalate themselves between these graphite layers. Since van der Waals forces are weak, they can intercalate themselves between these layers for forming LiC6. This process is called intercalation. So and once these lithium ions are here, electron is also supplied from the source itself. So giving forming LiC6. Like there's no ion when they are interconnected. This is a stable structure since there is no ion present. Now uh, when there's a load attached here, so what happens is the reverse of this process. Lithium ions, lithium ions get formed in these graphite between layers. The intercalated lithium ions dissociate, and these lithium ions again flow from this. This is called a separator. So, its only function is that anything beyond lithium ion cannot pass through this film. Only lithium ions can pass through in any direction possible. No other no other compound will pass through from here to here or here to here. Okay. So lithium ion again flow, and they just attach themselves to this lithium cobalt oxide, and again electron flows from the load, and here they again attach themselves to lithium ion, forming lithium cobalt oxide. So while discharging, the electron flow is from here to here, and while discharging, electron flow is from here to here. Uh, Everyone got it? Any doubts so far?
Are you sharing a screen?
No, I'm sharing the whiteboard. I'm writing there for now.
I can't see it. Like I just joined.
Okay. There's no option to watch the whiteboard.
No.
Just look at chat once and let me see them.
Okay. A chat. Like I just joined, so I don't think like
Yeah,
if it was in the
yeah, I
chat,
saw that.
uh, can you resend the link?
I mean, I just opened it from here and I never shared a link. So I'm not sure where to share the link from. Just looking. Then again, I was just
So
switching
there
off
is
the
an
whiteboard.
option to open
So
in
we'll find.
browser, so you can send a link
Yeah.
that link in the chat box.
Mushir, are you on
Okay.
phone? It could be because of that.
No, I'm on laptop, but on Chrome, not the P map.
Yeah.
Okay. I got the link. I'm sharing.
Okay, okay. Praneeth shared the link. Thanks.
Okay. Yeah. Just give me a minute. My battery is low. Uh, yeah. Okay. So any doubts so far?
Mm.
Uh, you can say no if there are no doubts. None, right?
No, no doubts.
No.
Okay. So just a minute. So this was about charging and discharging. Okay. So this is a simple table comparing lithium ion and lithium polymer. So the main differences are the electrolyte in lithium ion is in liquid form, and lithium polymer it's generally gel or solid. And shape, yeah, I mean polymer it says a flexible pouch, but the recent studies say that these the flexible pouch shape method generally results in lower cycles. So even lithium polymers have started coming in sturdy not cylindrical but rectangular cuboidal shapes. If anybody has seen the recent lithium polymer batteries used in drones and stuff, you can see that they come in hard cuboidal thing. So this was a recent development, like 5 years back. This is kind of old data. So energy density, yeah, it's lithium polymer has lower energy density. Can anybody just from the name tell what is energy density?
I mean, how much energy the battery can store, like in the form of chemical energy.
Yeah, yeah. When you talk about electrical storage devices, there's either batteries, fuel cells, conventional capacitors, or supercapacitors. So when comparing these, capacitors tend to give us very high energy for a small time. So they are high power density devices, whereas batteries and fuel cells give a particular energy for a long time. So they have higher energy density. So when comparing between lithium ion and lithium polymer, lithium ion tend to have a higher time. Like they can provide the same energy for higher time as compared to lithium polymer. But the thing is the energy it can provide is less as compared to lithium polymer. Like in drones, we have to run the BLDC motors, which requires high current, which lithium ion is unable to give. Which is why lithium polymer is also used. Lithium ion is also used. So going to the next part, uh, BMS. So Samir, if will take over from here.
Yeah. So from the name, can any one of you guess?
Like it's a device, it's like a circuit board that monitors the battery. So your charge, how much charge you have in your battery, the discharge rate, or how it's going to control the power dissipation. All of that is the part of the BMS. It's a circuit board that controls all of that.
Yeah. Uh, like almost correct. Okay. So yeah, from the name, basically, you can understand most of the things. Is say, for example, n number of batteries are connected. Okay, by the way, what's the difference between a battery and a cell? That's an interesting question.
Batteries is a series of cells together, right?
Just only series, or maybe a combination of series and
I mean,
parallel?
it's a sequence of cells together. I think that's a better
Yeah,
phrasing of.
yeah. So basically, battery is sequence or combination of series and parallel cells connected together. And so when we are connecting this to a load, basically, what is a load? Load is something that takes up current from the battery. So, okay. So what happens is that even if you are buying like 5 or 6 batteries, like a simple lithium-ion battery, which is 18650 type, and you are buying in bulk, so maybe 5 to 6. Okay, so you won't be finding all the batteries of same configuration. Like what I'm trying to say is that no battery is same. Okay, so what happens is like sometimes one of the battery may discharge faster than the other. One of them maybe uh, like can provide more current than the other, but and that's how all the batteries are different from each other. So here lies a very uh, question of concern that how to determine if a battery is Is that D? Yeah, Praneeth. Okay, sure. Okay, I'm continuing. So yeah, what can happen if I connect some good batteries with some bad batteries? What can be the possible outcome?
I mean, bad batteries as in like what
Bad
type of
batteries means say old batteries. Just think of it as old battery. Okay, just a simple analogy. What happens when you connect a torch, like when you connect batteries to a torch with some like new batteries and some old batteries? What happens?
isn't it uh, like you won't be able to get a proper power dissipation because the net voltage level will be lower.
Kind of correct, but uh, I wanted a like detailed solution. I mean, maybe a detailed answer. Anyone can give.
I'm not really sure how to phrase it properly.
So whatever you can say. Right.
So when cells are in parallel series, the entire battery to work, every cell should be right? Like it should be proper, every cell should be proper. If one of the cell is not like proper, then because like in except then series means it creates problem.
Okay, so uh, what happens is like when your batteries are in series, the battery which has a low charge, it gets stressed, right?
Rest in the sense.
So take ah. So I'm just continuing from whatever doing that. Okay, so can you see, guys? Uh, I'm shifted towards the right. Okay, so just follow. So say for example, the this is a battery which is connected to another battery and another battery. And this is connected to a load. If this battery is 3.5 volts, this is at 4, this is at 4. What can possibly happen?
The battery may neutralize each other to be matlab, at equal volt.
Okay, I'm just giving you the solution basically. So the battery can be modeled as a battery and a series resistance, which is also called internal resistance. Okay, so what happens is the total potential between this pin and this pin gets summed up to like what is it, 11.5, and the resistances, the internal resistance. Do you know why I am telling internal resistances?
I think because it's like not in our control, like internal resistance
See,
changes.
okay, so what's a battery? So it is a electrolytic cell, right? Electrochemical cell, maybe. Understandable what I'm saying.
Yeah.
Yes.
So what
Yeah.
happens is some kind of chemical reaction is going on inside a battery, which causes resistances to the current that is flowing through. Okay. So when there is an external load in here and there are internal resistances in here, what happens is like this has a less voltage right in here. So if a current flowing through this is I, and this current, a current flowing through this is uh, maybe, what will happen? Same current will flow through every one of them, right? So what happens is, do you know what is the formula for heating?
I square.
Yeah.
So what happens is this battery gets less heated up with respect to this one. Okay, I'm a bit clumsy. Yeah, so this battery and this battery gets heated up more than this battery. Okay. So what happens is as they are getting heated up, the chemical reactions are getting sped up. The resistance is also increasing, that is further increasing their temperature, and the battery health gets decreased. So what happens is like the fully charged battery gets discharged very soon for this battery which is old. Okay. On the contrary, when we are using battery in parallel, I'm drawing just below it, just follow it. Okay. Yeah. So what happens is like the resistances are in parallel, internal resistances are in parallel, so that won't be an effect. But when this is at 3.5 and this is at 4, maybe this is at 1, what happens is due to the low like battery state of the this battery, this gets discharged to this to get a equal voltage like V out is nearly equal to 3.8 or maybe something. Understandable. So what happens is like this battery tries to charge this, and this voltage gets decreased, this voltage gets increased. Okay, this also gets decreased a bit. So that's how the battery gets maybe like discharged soon, or maybe the battery health gets affected. Okay, so I'm shifting towards the left. Yeah. So what we can do is, say for example, there is a battery which is bad. Okay. It is labeled as bad. What does it mean? Anyone? Yeah, just say it.
I'm sorry, but could you repeat your question once more? I got broken up.
Yeah, so I am telling that, say for example, this is a battery which is labeled as bad. What does that mean?
Labeled as
Sometimes we,
what?
yeah, sometimes we say, right, that this is a bad battery, this is a good battery, this is average. So what does that mean?
Bad could mean like either it's not outputting some necessary voltage or the discharge rate is not good.
Okay, so when we connect a bad battery to some load, maybe some resistance. Okay, so how to check if it's a bad battery? We decrease the resistance, and which increases the current. So what happens is when a bad battery is connected to a high load, which means low resistance, it gets okay. So you guys know, right, that there is a uh, like minimal voltage at which a battery can work. So if there is a battery, it has a working voltage of say like 3.5 to 4.2, and the minimal, I mean the average voltage which is rated is 3.7. Okay. So when the battery voltage decreases below 3.4, 3.5 to maybe 3, what happens is the free charges between the two electrodes get so much saturated near the electrodes that it doesn't try to get dissociated into ions. Okay. So that's when we call a battery dead. So what happens? It
अच्छा, can you
doesn't.
just repeat that part कि मतलब
Yeah.
when that average volt से नीचे हो जाता है the total volt.
Yes. So, uh, am I good at English, or may I continue in Hindi? Because
No, no, it's okay. English is okay, fine.
okay, okay. So yeah, what happens is there are two terminals in a battery, right? So what happens is when there is a charging, electron flows from say plus to minus, and when there is a discharge, the electron goes from here and enters the plus. So what happens is when it is charging, uh, the electrons are getting accumulated in here, right? And what it means, the positive holes are getting accumulated in here. So this increases the voltage difference between the two terminals.
But the voltage that is present across that terminal generally depends upon the chemical potential na, between that two chemical
Yeah, this
compound.
this is actually the chemical potential, right? So
Yeah,
when there is a like transfer of carrier between one terminal to the other terminal, that increases the chemical potential between the two terminals, right?
yeah.
Increases or maybe decreases. So okay, changes. So what happens is when we charge a battery, we connect the positive side to plus and the negative side to minus of the charger. So what it happens, what it does, it sucks up the electrons from the positive uh, terminal and pushes all the electrons in the negative terminal. So what it results? It results in increasing the overall voltage between the two terminals. Understood? So
Yeah.
this voltage, this potential increases, this potential decreases, and so the delta V increases. Okay.
So, but then also only the number of that atoms decreases now on that pole on that terminal.
The number of electrodes, maybe electrons, to be honest. I'm sorry.
Yeah, but that connection, matlab that is like that parallel voltage source. It is like so number should not depend. Matlab that voltage should not depend upon the number.
Sorry, repeat your question.
I mean that it's uh, it's like quite parallel, so that voltage across the terminal should never depend upon the number of not electron, but the number of chemical compound present at each terminal. I mean that the amount of atoms, amount of that lithium carbide, Li6 atom, should not
Hmm.
change the voltage, because it does not, that voltage does not depend upon the amount of any chemical compound. It just depend ki there is that chemical potential difference.
Yeah, to answer that, uh, yeah, the thing is, how much Li6 is present when charged. That determines what amount of active material of a battery is present. So this active material keeps deteriorating while being used, being discharged. So it affects the voltage, and due to that, hmm, whole thing is affected, and whatever this he said stands true. Since the active material of a battery keeps changing based on what percentage of battery is charged. Even on phone this happens. Just there are better BMS circuits which handle it at low charge too. That's the only difference.
So yeah,
Okay,
got it.
so continuing from this, I hope you understood what was the what he answered. Okay, um,
Yeah.
have you understood? Okay,
Yeah,
so
yeah.
what happens is okay, just for simplicity, I am taking this as ground. Okay, so what happens is, say it's a one terminal is at 3.7. It is going through a resistance, some current, and when the resistance decreases, current increases. Understandable to all? What it means that there is a ample amount of positive charges in here, and there is neutral or maybe negatives. Okay, I mean electrons in here. So what happens is electrons flow from here to the top to like decrease the voltage and maybe decrease the potential difference. It's what diffusion does, right? Sorry, drift. Do you know what is drift?
What?
Drift, drift.
Yeah, that drift current. Yeah.
Okay, sorry. So yeah, when there is a potential difference between the two terminals, there is a drift. So what happens is, like even if you keep a battery open in air, uh, the positive terminals get like current. Okay, both the terminals are in contact with the atmosphere. So the air around it gets dissociated. Electrons get accumulated in the positive terminal, and electrons from the negative terminals are released from the negative terminal of the battery. Okay, to the atmosphere. Okay, so that's how a battery which is kept in the atmosphere gets dead or maybe gets drained after some days. Okay, so I'm not going into more details about how a battery is considered good or bad. I will just say is, when a battery is uh, able to give its rated output, or maybe the current it is supposed to provide, then it is called a good battery. when the current when while providing that current, the battery voltage gets decreased to a certain level. It's called average. And when a battery is unable to provide the current, or maybe while providing the current, the battery voltage gets dipped by a huge amount, it is called a bad battery. As Rohit has told in the starting of this session, that battery that we use are not ideal. So the voltage dips by some. Okay. So what happens is, like, for a good battery, if I am pulling out 1 ampere, change the color. Say I am pulling out 1 ampere for all from all of them. Okay. And the initial no load condition. Okay. By the way, are you understanding what I'm saying, or I'm just talking to myself?
No, we understand.
Uh, that's a bit loose voice. So you can just tell me if you are not understanding, or if you are not finding my pain. Hello.
No, no, we understand. Your pen is also visible.
Okay. So yeah. So say all of these batteries are similar in look, and the initial voltage when we measured are all at 4.1. But when I am connecting a resistance of, say, okay, of 4.1 ohms to all, it must provide a current of 1 ampere, right?
Yeah.
What happens is that, shifting towards a left a bit, just follow my pen. So what happens for a bad battery, the voltage dips from 4.1 straight to maybe 3.1. For a good battery, it drops from 4.1 to 4.05. And for an average battery, the voltage maybe dips from 4.1 to like 3.9. So what happens is, this is capable of providing nearly equal to 1 ampere. This also provides nearly 0.9 amps, but this is unable to provide such a huge current, and this provides nearly 0.75 amps. Okay.
Yeah.
So why this voltage dips? Any idea? I think Rohit has told a bit about it, right?
I mean, is it because the electrolyte is being used too quickly?
So when, say, for example, uh, yeah, still staying on the left side. So when, say, this is the two electrodes within a cell, when there is like electrons at all around this layer, okay, so it can give a huge current, right? Following?
Yeah.
But say this part of the uh, terminals are saturated, which means that this like charges near these portions are a bit off, maybe, or maybe this doesn't get dissociated. So what will happen? Only this part will be used, right? Only this part will be used. So as you know that current is directly proportional to what? Current is directly proportional to
Yeah.
okay. So yeah, and it is also proportional to width and the length, because the solvent between this, the solvent which is lying in here is actually the what? It's a resistance, right?
Yeah.
Yeah.
So when I'm connecting a battery to a external resistance, what it will happen? The uh, okay, okay, going a little down for the reference. Yeah. So as I have told, a battery can be modeled as a potential and a resistance. So when this resistance is high, the internal resistance is high, so it won't allow a huge current to flow through this, right? When this resistance is low, it will allow a huge amount of current to flow. So that is the limiting factor to the discharge current. Okay. Now what happens is, if there is, say for example, a good battery, a bad battery, and average battery. Okay. So say all of them are in parallel. So while providing say 3 amps, what happens is the good battery provides more current, like is able to provide more current than the bad battery, because the voltage at which all of this are is at same level, right? Because they are in parallel. To maintain this parallel this voltage across the terminals of all the batteries, the current discharged through the batteries gets changed. So maybe this is giving a huge current, this is giving less current, this is giving average amount of current. So what happens is, it stresses the bad battery as well as the good battery. Okay, this type of imbalance does this. Avoid this kind of stuff, what some scientists have created is the BMS. So what is a BMS? It connects each of the batteries to a particular board, and then gives the output based upon what a battery can give. Understandable? Whatever the current the battery can give. So it basically balances the stress on the batteries and thus increases the health of the battery, or maybe battery life of the battery. Okay. So as you can see in the presentation, okay, yeah. So as you can see the presentation, that PMS is a kind of brain of the battery pack, which monitors voltage, current, and the temperature from a battery. It also balances the cells, to ensure that battery is uniformly discharging and no battery is getting stressed too. So, also, it has some protocols so that uh, over current or over voltage is not like fed into or maybe fed out of the battery cell. I'm sorry, battery pack. Okay. So from the drawing, you can see, or maybe the image that is available in here. There is a discharger, there is a cell balancing equipment, there's a measurement of different parameters like temperature, current, and the voltage states. After that, it uses a chip or maybe the controller unit to estimate the state of charge, state of health, thermal management, and also the capability estimation of the battery. Okay, so now I want to ask you guys a basic question. Uh, what do you mean by state of charge and state of health? Does anyone know?
I have like read a little bit of it. Um, uh, State of charge is essentially how much battery it's able to store. It's like the closest thing to the battery estimation.
Okay.
Um,
Anything
like
else?
I
What is the
mean,
difference between state of charge and state of health?
state of uh, like मैं I'm not able to tell in words पर अभी but मुझको थोड़ा बहुत आइडिया है मतलब I'm not able to phrase it right now. I think it's better like
हाँ ठीक है, जितना है उतना ही करो। जितना आइडिया है उतना ही बताओ।
I think
ओके, सो बेसिक क्वेश्चन, हमारे फोन्स में जो बैटरी का जो होता है ना, परसेंटेज दिखाते हैं, तो बैटरी परसेंटेज कैसे दिखाते हैं?
मैं क्या बोला फिर से बता
फोन में या फिर लैपटॉप जो बैटरी का परसेंटेज दिखाता है, इट शोज अ परसेंटेज ऑफ बैटरी इन
हाँ
लैपटॉप्स एंड मोबाइल फोन्स, सो हाउ इज दैट कैलकुलेटेड?
that comes
एनी
from
आइडिया?
state of charge like
रेट ऑफ चार्ज।
हाँ
फिर स्टेट ऑफ चार्ज का मतलब क्या है, मतलब कैसे कैलकुलेट कैसे करते हैं उसको, कुछ देख के तो करेंगे ना। I've told different types of things like voltage, temperature, current, किसको देख के ये करता है? कोई आइडिया नहीं है?
अभी याद नहीं आ रहा है
Okay, so state of charge means the like it can be calculated in different methods, but what it means is that how much percentage of the battery, maybe voltage or maybe the charge it holds is now available inside the voltage. Okay, so for voltage measurements, what it does that first it takes up the highest battery voltage the battery can go, and then it checks the lowest battery voltage it can go. Understood? And now this is the whole range of the battery operation. And when a battery operates between 3.5 to 4.2 voltage, if the and currently the battery voltage is at 3.8, you can obviously do the math, right? How much is the battery percentage right now? So basically, that say whatever example I have given, it is 0.7 volts range, right? So if a battery is at 3.8 volts, so it is at 0.3 volt higher than the lowest battery state, lowest battery voltage. So what will be the battery percentage? 0.3 by 0.7, which is equal to nearly equal to 42%. Understandable? Okay. Another method is like the charge a battery holds. So what happens is like there is a term MAH in every battery. Do you know what that means? Just tell me from the unit.
Milliampere hour, right? That
MAH. So what does that mean? Current into time.
Yeah.
So what's that?
Power. Nice. Sorry.
Take your time. Don't hurry. Give me this answer. Current into time. Come on, guys.
Charge that. A charge.
Okay. So yeah, charge. So what does that mean? Is say if a battery is rated as 3000 mAh, it means that it is able to give 3000 milliampere for 1 hour, which means that 3 ampere for an hour. So you can obviously do the math to get the total current or maybe the total charge that the battery stores. Okay. So when a BMS is programmed first time to check the battery pack, what it does, it checks how much of the battery maybe. Okay, BMS works a little bit differently. So it uses both the protocols all together, both the battery voltage level and the battery charge level. Okay. So say for example, a battery has 3000 mAh, and if I drain it to 50%, the battery coulomb maybe I mean the charge will be like 1500 mAh. So I'm just telling in very bad terms basically, but just get the idea of it. Okay. So the charge which is available in the battery right now, after the battery is drained to 50%, will be 3000 milliamps into 3600 seconds. So that's the charge which is available in the battery. So what this BMS does is calculates the current into time of the battery which is connected to it, and then it just subtracts it from the actual capacity of the battery so that it can get an estimate of the battery percentage. Understood? This is the second protocol. Hello, everyone. Okay. anyone else or only Sujal is understanding? Yeah, uh, I mean, don't react, just unmute and just say. Okay. So yeah. So basically, what happens is that generally BMS uses a combination of both of this to calculate the state of charge of a battery. So it checks the battery voltage, and it also checks the amount of charge discharged from the battery. Okay. So from that, it estimates the state of charge of the battery. So what the battery percentage is, right? Okay. What happens is that, say for example, if a battery is designed to hold a capacity of 3000 mAh and the battery voltage is say 3.7 volts, but in actual the battery is only able to store a charge of 80% of the designed specifications, or maybe the battery voltage is only able to reach to 4.1 rather than 4.2. Okay, so that is an estimate of the state of health, which means how good or bad the battery is. Say, for example, the designed range of battery operation is 3.5 to 4.2 volts, and the battery can only reach 4.1 volts, uh, like after say 1 year of usage. Okay, so what it means that the battery health has been degraded by 1/7. Okay. On the contrary, if say the battery is designed to be to operate at like 3000 mAh, like the battery capacity is 3000 mAh, but the battery voltage reaches to 4.2 at like the charge of 2500 mAh. Okay, so what that means is the battery health has degraded by 1/6. किसी को कुछ डाउट है, कुछ समझ नहीं आ रहा है, वो भी बता दो, क्योंकि मुझे समझ नहीं आ रहा कि तुम लोग को समझ आ रहा है कि नहीं.
No, we are getting it.
ठीक है. द थिंग आई हैव टोल्ड कि बैटरी वोल्टेज विद इन लिमिट्स रहनी चाहिए. तो बीएमएस क्या करता है कि डिपेंडिंग अपॉन ईच बैटरी इट जस्ट चेक्स कि बैटरी का जो वोल्टेज है वो वोल्टेज रेंज के बाहर ना चला जाए बैटरी का वोल्टेज. तो बेसिकली व्हाट हैपेंस इज लाइक से a battery is at 3.5 volts and you are still drawing current from it. तो क्या होता है कि अंदर के जो केमिकल्स होते हैं ना सैचुरेट हो जाते हैं. तो उसके बाद मतलब कभी कभार होता है कि बैटरी का जो हेल्थ है ना वो बहुत ज्यादा डिग्रेड हो जाता है, मे बी, या फिर बैटरी चार्ज नहीं होना चाहता. ठीक है, बैटरी का चार्जिंग स्पीड बहुत कम हो जाता है. दैट्स व्हाट हैपेंस व्हेन यू यूज योर फोन्स मे बी एट लो वोल्टेजेस फॉर लॉन्ग. ठीक है, तो अच्छा, तो ये तो है एक बात. इसके बेसिस पे हमारा जो बीएमएस है, बीएमएस वोल्टेज भी सेंस करता है, करंट भी सेंस करता है, एंड देयर आर डिफरेंट प्रोटोकॉल्स टू check the over voltage and over current as well. सेल बैलेंसिंग, किसी को समझ आ रहा है कि मैंने ये चीज ऑलरेडी कवर कर चुका हूँ?
Yes.
तो पैसिव बैलेंसिंग मतलब हायर वोल्टेज जो सेल्स में है उससे थोड़ा ज्यादा करंट लेता है बट बहुत ज्यादा नहीं। एंड एक्टिव बैलेंसिंग इज लाइक चार्ज रीडिस्ट्रीब्यूट करना, जैसे कि मैंने बोला था इससे पहले भी, ठीक है। बट जो होता है कि जब हम एक्टिव बैलेंस यूज करते हैं ना बीएमएस में, तो वो डायरेक्टली पैरेलल में नहीं रहता, इन रैदर बैटरी के थ्रू, मतलब बीएमएस के थ्रू जाता है, ताकि बहुत ज्यादा करंट भी हमारे बैटरी के अंदर ना चले जाए, ठीक है, विच कैन ऑल्सो कॉज बैटरी टू ओवरहीट। ठीक है। टाइप्स ऑफ प्रोटेक्शन विच इज डन बाय बीएमएस ओवर वोल्टेज। जब हमारा जो वोल्टेज इनपुट वोल्टेज सोर्स लो, वी आर गिविंग 5 volts to 3.7 volt बैटरी, ठीक है। तो क्या होता है कि बीएमएस जस्ट शट्स ऑफ, ठीक है, कि मैं चार्ज करने नहीं दूँ, but say 4.2 volts and battery is designed to operate at 4.2 volts at maximum, ठीक है। तो क्या होता है, अभी का जो नॉमिनल वोल्टेज इज 3.7 मे बी, ठीक है, तो वो क्या करता है, हायर वोल्टेज देके अक्रॉस द बैटरी वो चार्ज करता है धीरे धीरे। इससे सभी को एक बहुत कॉमन क्वेश्चन आएगा कि हमारा जो फोन के चार्जर्स है, फोन के चार्जर्स क्या होते हैं, 5 वोल्ट्स होते हैं, 5 वोल्ट्स आउटपुट देते हैं, बट द फोन के अंदर जो है, फोन के अंदर का बैटरी 3.7 वोल्ट है या फिर 4.2 वोल्ट है एट मैक्सिमम, राइट।
या
तो हमारा जो बैटरी है फोन के अंदर, वो कैसे संभाल लेता है वो चीज? द आंसर इज बीएमएस। फोन के बैटरीज जो है, फोन के बैटरीज आर टोटली स्मार्ट बैटरीज बेसिकली। उसके अंदर बीएमएस रहते हैं, मतलब हर एक सेल के अंदर बीएमएस रहते हैं, ठीक है, जिसके वजह से हम हर एक सेल का जो डिस्चार्ज करंट, डिस्चार्ज वोल्टेज या फिर चार्जिंग करंट, चार्जिंग वोल्टेज, ठीक है, ओवर वोल्टेज करंट प्रोटेक्शन, टेम्परेचर मैनेजमेंट, हर एक चीज, हर एक सेल का अलग अलग से हम देख सकते हैं, ठीक है। एंड हमारा 5 वोल्ट इनपुट हो रहा है, बीएमएस के थ्रू जा रहा है। बीएमएस क्या बोलते हैं, मैं तुम्हें पूरा चार्ज करने नहीं दूंगा एट 5 वोल्ट। तो वो क्या करता है, एक रेटेड वोल्टेज दे देता है अपना जो बैटरी है, बैटरी के अक्रॉस, एंड बाकी जो भी वोल्टेज है वो वोल्टेज आइदर एक रेजिस्टर के अक्रॉस जाता है या फिर एक कुछ डायोड है, डायोड के थ्रू जाता है, हाँ, मे बी ऐसा कुछ ये लोग करते हैं, ठीक है। एंड ऑब्वियसली यू गाइस नो व्हाट इज अ जेनर डायोड, आई गेस पता है ना जेनर डायोड क्या है?
या
Yes.
Yeah.
तो जेनर डायोड इन रिवर्स बायस क्या करता है, जेनर ब्रेकडाउन होता है, राइट। जेनर ब्रेकडाउन क्या करता है,
इनफाइनाइट करंट उसे पास हो सकता है।
हाँ, तो एक्सेस करंट पास होता है, मतलब क्या, वो एक पर्टिकुलर वोल्टेज सेट कर रहा है एक बैटरी के अक्रॉस। सो मैं ये चीज बहुत सिंपलिस्टिक वे में बोला, पर बीएमएस में ये यही सेम चीज बहुत कॉम्प्लिकेटेड वे में होता है यूजिंग ट्रांजिस्टर्स, ठीक है। जब अंडर वोल्टेज, मतलब एक बैटरी ऑपरेटिंग वोल्टेज के नीचे बैटरी वोल्टेज चला जाता है, तो डिस्चार्जिंग बंद कर देता है, मतलब वो वाला पर्टिकुलर जो बैटरी है उस बैटरी को मतलब बैटरी से पावर खींचना बंद कर देता है। ओवर करंट समझ ही आ रहा होगा कि कैसे ओवर करंट प्रोटेक्शन होता है, ठीक है। शॉर्ट सर्किट मतलब बहुत हाई अमाउंट ऑफ करंट अगर चला गया, ठीक है, तो इंस्टेंटली पूरा सिस्टम बंद कर देता है। ओवर टेम्परेचर जब होता है एक बैटरी का, तब क्या करता है वो, चार्जिंग या डिस्चार्जिंग दोनों के टाइम बैटरी ऑब्वियसली हीट अप होता है बिकॉज ऑफ ह्यूज अमाउंट ऑफ चार्ज फ्लोइंग फ्रॉम द टर्मिनल्स, ठीक है। तो उसको प्रिवेंट करने के लिए थोड़ी देर के लिए या तो चार्जिंग डिस्चार्जिंग बंद कर देता है, या तो बैटरी का जो चार्जिंग डिस्चार्जिंग रेट है वो कम कर देता है, ठीक है। मूविंग टू द नेक्स्ट स्लाइड। चार्जिंग कंट्रोल कैसे करते हैं ये, बेसिकली चार्जर का जो कनेक्टिंग मतलब जो वोल्टेज जो आ रहा है या जो करंट आ रहा है उसको रेगुलेट करके ये भेजता है बैटरीज पे, ठीक है। एंड कंटिन्यूअस मॉनिटरिंग करता है हर एक बैटरी का स्टेट ऑफ चार्ज का, सो दैट बेसिकली जो बैड बैटरीज अगर जल्दी से अपना पहुंच गया अपने जो रेटेड वोल्टेज है, वोल्टेज अपर लिमिट, तो वो चार्ज करना बंद कर देता है, या फिर अगर क्या बोलते हैं, हाँ मतलब वही है कि अगर जल्दी से पहुंच गया तो उसका चार्जिंग बंद कर देता है। एंड अच्छे बैटरीज आर कैपेबल ऑफ कीपिंग मोर चार्ज विद इन इट, तो वो तभी भी चार्ज होते रहता है, ठीक है। कम्युनिकेशन विद बीएमएस, मतलब बीएमएस के अंदर एक लॉग बुक भी रहता है कुछ कुछ बीएमएस में, दैट स्टोर्स द बैटरी डेटा अबाउट ईच ऑफ द बैटरीज इट होल्ड्स, ठीक है। जो कि हम अभी आईओटी में भी देख सकते हैं। आईओटी मतलब इंटरनेट ऑफ थिंग्स। बहुत लोगों को शायद पता भी होगा कि ईवी जो होता है ना, ईवी के अंदर जो बैटरी रहता है उस बैटरी के हर एक सेल का जो हेल्थ है या फिर हर एक सेल का जो स्टेट ऑफ चार्ज है, दैट इज बीइंग मॉनिटर्ड यूजिंग अ स्मार्ट वेयर्स which then connects to monitor, and the data is uploaded to the cloud, ठीक है। तो क्लाउड में क्या होता है, ये जो डेटा आ रहा है ना, बैटरी का स्टेट, बैटरी का डिस्चार्ज चार्ज, ये सब, ठीक है, दैट्स बेसिकली लॉग इनसाइड द बीएमएस। तो ये लॉगिंग डेटा जो है इसको बाद में एनालाइज किया जाता है टू एनालाइज व्हिच बैटरी इज बैड, व्हिच बैटरी इज गुड, एंड उस हिसाब से ईवी का जो ओनर है या फिर ईवी का जो सप्लायर है या फिर बैटरी टेक्नीशियन है, वो बेसिकली बैटरीज को उस हिसाब से चेंज करता है या फिर कुछ भी करता है, ठीक है, बैटरीज पे। एंड कम्युनिकेशन प्रोटोकॉल्स में पता ही है, लाइक कल परसों हम लोग ये सब रिलेटेड डिस्कस किए ही है। मूविंग टू द नेक्स्ट स्लाइड। स्टेट ऑफ चार्ज एंड स्टेट ऑफ हेल्थ मैंने ऑलरेडी बता दिया है। टाइप्स ऑफ बीएमएस, हाँ ये थोड़ा बोलना पड़ेगा कि बीएमएस के जो कंपोनेंट्स है, AAP basically is use the cell voltages and temperature। MCU मतलब वो डिसाइड करता है कि इस बैटरी को, ये बैटरी फुल चार्ज है या ये बैटरी डिस्चार्ज है, या फिर इस बैटरी का टेम्परेचर बहुत ज्यादा है इसको नहीं चार्ज कर सकते, ठीक है, ऐसा। ये सब सारे डिसीजंस एमसीयू लेता है। MOSFETs basically are the electronic switches जो कि लोड से चार्ज कनेक्ट या डिस्कनेक्ट करता है, लाइक इट्स काइंड ऑफ एक्चुएटर ऑफ अ बीएमएस, ठीक है। सेल का ओवर करंट हो गया तो अचानक से उसका कनेक्शन कट ऑफ, तो वो मॉसफेट से होता है from by using the signals which is provided from the MC। Balancing resistors are for passive balancing, and NPC sensors with the full form of which is negative temperature coefficient sensors। ये क्या करता है कि इस मतलब जितना टेम्परेचर ज्यादा होगा इसका रेजिस्टेंस उतना कम हो जाता है, ठीक है। सो रीडिंग द वोल्टेज अक्रॉस दिस सेंसर्स हम लोग टेम्परेचर को मेजर कर सकते हैं। इसके कॉन्ट्रारी में होता है पीटीसीबी, पॉजिटिव टेम्परेचर कोएफिशिएंट। बैटरी वोल्टेज मतलब वोल्टेज अक्रॉस सेंसर बढ़ेगा विद टेम्परेचर, तो उससे भी हम देख सकते हैं। मूविंग टू द नेक्स्ट स्लाइड। चार्जिंग मेथड्स। आर्यन, I mean, राम, ठीक है। मतलब बहुत कॉमन चीज है ये कि एक बैटरी को अच्छा भाई तुम लोगों को समझ आ रहा है या फिर बस सुन रहे हो, समझ नहीं रहे हो कुछ?
नहीं समझ आ रहा है।
Yeah, we are
ओके
understand.
ओके। ये स्टार्ट करने के पहले मैं एक चीज बताना चाहता हूँ कि बैटरी, हर एक बैटरी के बॉडी में तीन डिटेल्स मेनली रहता है। एक रेटेड वोल्टेज, एक रेटेड लाइक चार्ज, और एक रेटेड करंट, which is also known as the C value of the battery. किसी को पता है C value का मतलब क्या है?
नो।
No.
Anyone else? Hold on. Okay. So basically, C value is that how much current a battery can draw or maybe discharge at a time. ठीक है? So say for example, a battery is at 3.7 volts and 5000 mAh and 1 C. So the current which it can provide, the the nominal current which it can provide is 5000 mAh into 1 C. Okay, just remove the H. Okay, so which means 5 ampere. ठीक है? हेलो, समझ आ रहा है?
या
So the higher is the C value, the higher is the current it can provide. So अगर 500 mAh का एक बैटरी है 3.7 volts which is rated 30 C, इसका मतलब ये है कि करंट डिस्चार्ज जो है ना इसका, ये करंट डिस्चार्ज क्या होगा? 0.5 into 30 amps. मतलब the battery can provide 15 amps of current without disintegrating its components. मतलब बैटरी के अंदर का जो टेम्परेचर है, वोल्टेज है, ठीक है, ये सब हैंडल कर लेगा, मतलब इतना करंट हैंडल कर लेगा इजी. And generally what happens is like this, what the C value is, the double is the instantaneous peak current draw. मतलब एक बैटरी अगर जस्ट एक लाइक 10 माइक्रोसेकंड, सॉरी 10 मिली सेकेंड्स के लिए भी अगर शॉर्ट सर्किट हो गया ना, तो बहुत एक ह्यूज करंट जाएगा, राइट? सो वो ह्यूज करंट का एम्पीरेज वैल्यू बहुत ज्यादा हो सकता है. सो से यही सेम बैटरी है 3.7 वोल्ट 500 mAh एंड 30 C. तो इसका नॉमिनल करंट ड्रॉ कैन बी कितना? 15 एम्प्स, राइट?
या
अब इसका इंस्टेंटेनियस करंट ड्रॉ विल बी 30 एम्प्स. अब डिपेंडिंग अपॉन डिफरेंट टोपोलॉजीज ऑफ बैटरी ये इधर उधर थोड़ा बहुत चेंज होता है. एंड I think Rohit would like to continue from here.
Hello, am I audible?
या
Yeah,
Yeah.
simple numerical type question. If a battery is has 7.3 volt rated and 5000 mAh. So it can if it has 5C, so if it is continuously giving 5C current, in how much time will it discharge?
Can you just repeat the initial part that
Yeah,
battery that mAh?
battery is rated at 7.2 volt, 5000 mAh, has 5C rating. If the load is requiring it to give 5C current continuously, in how much time will it discharge?
One by 5 hour, 12 minute.
Yeah, exactly. Yeah, exactly correct. So, you don't need what is mAh, what is voltage, but depending on what rating it is, you can just calculate how much time will it take to discharge with giving the continuous rating current. For 4C, it would be 15 minutes, 5C, 12 minutes, 3C would be 20 minutes. So yeah, so continuing towards charging methods for batteries, uh, there are basically two ways. You can either give constant current to a battery or constant voltage to a battery. In constant current, the voltage rises, and in constant voltage, the voltage is fixed. The current shifts as it's being charged. The ideal method for lithium ion is uh, till 80% to constant current, and then for constant voltage go from 80 to 100. Now, can someone tell me why is common current faster? It's simple, intuitive. If you just think about the Ohm's law method, you should be able to give it.
Can you just repeat the question?
Why constant current method is fast charging? And in whiteboard, I have shifted totally to the right, so accordingly you can zoom in to see. So any intuitive answers?
As the charging of the battery increases, it may happen that the resistance across that electrolyte may also increase. So the current will
So
decrease.
no, not that. Okay, it rise rooted in the basic IR characters IVR thing. So take this as a battery. When you are applying a voltage, uh, if you are applying a voltage, the current internal resistance. Oh, sorry, just a minute. By the way, does everybody is able to see where I'm writing right now, right? Hello.
Yeah.
Yep.
Huh? If anybody is not able to see, just shift right from everything that has been written. You will be able to find it. Okay. So giving uh, while charging a battery, you have internal resistance in series. due to which the total current charging the battery decreases. Like not sorry, there will be a voltage drop across the battery. But if you think about constant current mode, the same resistance is in parallel. I mean, even though charging source has its own, so current source has a uh, uh, internal resistance RS, and battery has a internal resistance RI. So uh, this evidently decreases the total resistance, which increases the charge going to the battery. But when you go to the constant voltage mode, these resistances are in series. So the total resistance in the circuit increases, which in the end decreases the charge going to the battery. Get my point? Understood? Hello, am I there in a bit?
Yeah.
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 Any doubts in this?
Like it's parallel and series. Like why is it changing in series and parallel? Like
Okay.
why is it in parallel in the first case and like in series in the second?
Okay. Uh, so it's a basic nomenclature which comes from the Ohm's law. Like like let's take a current source. In current source, you just know the direction and amperage flowing through the getting out of the current source. So if I attach a resistance in series and there's load, can anybody tell what's the current flowing through the load here?
Yeah, the same current.
Same
Yeah, but when I uh, apply the internal resistance in the parallel, is it the same current flowing through the load?
No.
Yeah.
thing.
So to represent the internal resistance taking up some loss, this internal resistance can be in real life can be characterized by heating issues or many various other things. So this loss is represented by the internal resistance, which is in parallel in current source. Same in voltage source, where when the resistance is in series, it creates a drop. So basically, there's a voltage drop across this resistor. There's a voltage drop across this resistor. So this represents the loss, which is why in voltage source the internal resistance is in series, and in current source it's in parallel. Same goes for the battery as well, since it's battery in itself is a source, but it's just acting as a load being charged. Got the point, Mujir?
Yes.
Okay. So just give me a minute. Okay. So coming to heating and safety. Again, same. High current causes internal resistance losses, generating heat. I square R losses. Uh, Anybody has a 65 watt or higher charger for mobile?
I think I have a 66.
Yeah. So you must be feeling the phone being heated after the charging is done. Since
Yeah.
the what is applied is higher.
Yes, yes.
And again, short circuit and damaged cells. Where when there's as Somideep said, in short circuit, a very high current flows in the small time. This high current will create even higher I square R losses since it's I square in the end. And thermal runaway is the effect that due to increase in current, there's increase in temperature. Due to increase in temperature, there's even more increase in current. So it's an unstoppable cycle. Get the point? So the third point, poor airflow and enclosure design. If the heat which should be dissipated is trapped, it will in itself destroy the battery from inside. If simple, you saw LiC6. If LiC6 compound has higher energy, what will happen? First, the Li bond will break, even though there's no dissociation in electrons. Then the carbon bonds will itself start to break in the graphite. So this results in damaging of the cell. So preventive measures, ventilation and airflow, simple. Thermal management using heat sinks, cooling plates, flame retardant casings. It's just making it fire resistant. And BMS is the main primary thing without which all of this will is bound to happen in high current applications. I have just a few final things to share. Okay, everybody has heard about cycles of a battery. What do you mean by that?
The number of times the battery can be charged and discharged.
Okay. Uh, what is general amount of cycles in a lithium-ion battery, which is present in a mobile phone?
Maybe 500.
Higher? Any other
I
guesses?
was talking about power bank.
Huh?
I
Okay.
remember that power bank has 500 cycles of charging and discharging.
Yeah, power bank. I was talking about battery in mobiles. The thing with power banks is power banks are at a very higher mAh. So it's a trade-off. You can either get higher mAh or higher cycles. So finding a sweet spot during designing is important. You when working on projects, you will have to design this. I mean, you will have to select the batteries based on this type of design. Like, do you want higher cycles or higher mAh? Okay. Any other guesses? What's in mobile?
It's close to 10K.
No, too high. Okay, I'll just tell it's between 1000 to 1500. Okay. Mm, as someone of you said, it's the one cycle is one charging and discharging. How much charge and discharge will create one cycle? Like there's a battery at 60%. I charge it to 100, charge it to 100, and then I let it discharge to 40, and then I charge again. And there's a battery which was at 20%. I charged it to 100%, and then I let it discharge to 10%. Which of these is a cycle? A full cycle?
10% one.
Mm, Let's take a poll. How many of you think 10% one? Raise your hands. Okay, three of you. How many of you think the other one? Others raise your down your hands. How many of you think the 60% one is? Okay, Siddharth,
I mean, I'm getting the
Vinay.
feel that it's none of them for some reason.
Okay, none of them. Third option. Does anyone feel it's both of them? Okay, assuming no one. Actually, it's both of them. Like it doesn't matter how much you charge or how much you discharge. You are charging a battery and then you are discharging and then you again charge. When you start charging again, one cycle is done. So take a mobile for example. If you are just charging from 60 to 90 and then letting it discharge, you are wasting away a cycle. So there are two mobiles. One mobile, let's take an example. Like Pratik uses a mobile, Mushir uses a mobile. Pratik generally tends to charge his mobile after it gets discharged below 30%. And Mushir tends to charge however he wishes, like depending on his schedule. Which mobile will have higher longevity of battery? Hello.
I mean, wouldn't it be the one that like you discharge and charge?
Yeah. So I mean, the thing is, the one who lets it discharge to the to 20% or below, and then lets it charge. The utilization of charge during a cycle is complete, more than 100%. So this uh, not more than 100%, roughly 80% of the charge is used during a cycle. So the number of cycles is limited. Like both of those phones have 1,000 cycles, but Mushir will be done with his cycles earlier than Pratik in this case. Get what I'm saying?
Yeah.
Yeah. So next time you're charging your phones, keep this in mind. Also, there's another thing. Uh, Nowadays there are 100-watt phone chargers, 150-watt chargers. What do you think they have an effect on the battery?
I mean, due to a very fast charging and heat, it could have some mal effects on the battery health itself, right? Like the electrolytic composition.
Close, but not fully. Anyone wants to add?
If we are increasing that what we are certainly increasing the temperature of the battery, so it may damage the battery.
Again, I mean, there's a better explanation. Let me just come to it. Uh, uh, so is everybody able to see what I'm drawing?
Yep.
Okay. So what happens during charging? Lithium ion gets dissociated from here, and then it intercalates between graphene. So graphene has to adjust to store the incoming lithium ion. What if I'm doing fast charging? So basically, before the battery can accommodate the received lithium ion, I am just forcing more and more. This causes structural instability, due to which graphite has compositional changes within, not compositional, structural changes within itself. So there's deformation of the anode, the graphite gets deformed within itself. Some chemical bonds start breaking. Some uh, distances between bonds get starting uneven, which in the end affects the health of a battery. S- But even to not let this happen, people are playing with the material itself rather than just sticking with graphite. People are starting to switch to better novel materials. Even the problem with lithium ion in itself is lithium is a rare metal. So with the type of usage we are doing, it's sure to run out. So we are also trying to look into other ions which can be used instead of lithium. Does anything come to mind which other material can be used instead of lithium ion?
Gallium.
Sodium.
Sodium, yes. Like lithium, sodium, potassium, they are all of the same column. So these are being used. Since sodium and potassium are available very easily. Within sodium and potassium, which will be more preferred? What do you think?
I think sodium is closer to lithium.
Uh, any particular reason sodium is more preferred than potassium? Except
I
closer.
think because of
Like
because of
closer
the
is not
weight,
the correct answer.
because of the
Yeah,
weight,
exactly.
maybe.
Yeah, exactly. Uh, and there's a flow of lithium ion happening under the influence of electric field applied by the potential source. To create a potassium ion battery, you'll have to apply much more voltage and electric field as compared to lithium ion, which is why potassium ion is rarely used, but it finds its applications. But whereas the world is moving towards sodium ion much faster. Even in our college, research is going on this sodium ion battery. If you pass from the main building towards the Netaji Auditorium, you will see a lab on right hand side. Professor Amrish Chandra, he's working on this. Uh, I guess that's it for today. I'll just stop recording. Give me a minute.